Dear students, welcome to the next class of data structures in algorithm. This is week 11 and I am Dr. Suhail. Uh, we, inshallah, will be continuing our discussion that we left when we were conducting our on-campus classes. It means that whatever we discussed in the previous week, uh, that was a little you, deviation from our uh, normal study of the data structures and their operations. Let's review what we studied in the previous week. Okay, so in the previous week we discussed about algorithms, and this was because we wanted to know we wanted to know when you are developing various data structures and developing their operations. So you do need to design those algorithms first. And in this course, the aim is to know about data structures as well as algorithms. And once you are trying to understand algorithms, then you need certain techniques how to evaluate or how to compare those two multiple algorithms. And when you know how to compare those algorithms, then you are able to decide if one algorithm is better than or uh, worse than the other one. So that is the main aim. So in previous week we studied about the difference between algorithm and a program. Both are a step-by-step representation of a procedure or task that we need our computers to perform for us. Then we studied about what is algorithm analysis, and we studied that there are two factors involved. The first one was time, the execution time for an algorithm, and the second evaluation or analysis factor was the space factor, that how much memory a specific algorithm takes when it executes. Okay, so both of these factors basically combine to evaluate or to analyze different algorithms. Then we studied time complexity of algorithms and space complexity. In the time complexity analysis of algorithms, we calculated a generic, you can say, a representation of the order of uh, unit times that an algorithm takes to execute fully from start to end. And similarly, for the space complexity, we studied or we found a generic representation of the words of memory, or units of memory that an algorithm consumes while it is executing. And for both these factors to be found, we used the frequency count method, and ultimately the final representation was the big O notation, which basically represents the worst case for the complexity of an algorithm. Okay, this week's content include continuation of the linked data structures, because previously we were talking about linked lists. So those are also linked data structures, and you know why we call it linked data structures, because we create individual objects in memory and then link them through pointers to the same object. So that's why, unlike an array, uh, we access random memory areas where those objects have been stored. Uh, unlike memory where, unlike array where you have contiguous memory location and indexes are available, index numbers are available for you to access individual elements in an array. So the same way we created linked list, we'll be discussing now another data structure that is called binary tree. As you know, binary means two, and tree is basically the structure of the data that we will be arranging. So it will be arranged, but different nodes of this tree will be arranged in a tree structure. And it is called binary tree because uh, every node has two children nodes. So we'll be discussing that later. This is basically the contents of this week's lecture. So we'll be discussing various terminologies, just like I mentioned, nodes and leaves and okay. Those terminologies and the rules for creation of binary tree. Then we'll be discussing some applications of the binary tree. Uh, Specifically, we will be talking about binary search trees because those are particularly important to computer science and software engineering. Uh, Actually, we will be implementing binary search trees. So we'll be studying the operations, various operations on binary search tree, and in this week, uh, hopefully, we will be implementing insertion. After creating the binary search tree, we will be developing code for the insertion traversal, which by the way are three types in a binary search tree: the pre-order traversal, in-order traversal, and the post-order traversal. So this is basically the content for this week's lectures. The target CLOs and taxonomy levels. So as we are studying new content, we will be discussing a new data structure and the operations associated with it. So these contents are mapped with CLO1, which is a taxonomy level 1. Taxonomy level means cognitive level 1 means that you need to understand the content and reproduce the same if uh, you are asked to. ठीक, सो उस पर्सपेक्टिव से आपने इसको स्टडी करना होगा। नया कंटेंट है, नए नए कॉन्सेप्ट्स आपकी समझ में आएंगे, आपको समझाए जाएंगे और फिर इसी किस्म के आपसे क्वेश्चंस भी कंटेंट में पूछा जाएगा। चूँकि आगे जाके हम जो इसका फर्दर इसमें काम करेंगे, सो दोज विल बी एट दी मच मोर एडवांस्ड लेवल्स एंड देन उसके उन CLOs के मुताबिक अगर आपसे क्वेश्चंस पूछे जाएंगे, देन दोज वुड बी at higher taxonomy levels, and you would be required to then modify or uh, update the concepts that you have learned in this lecture. Okay, so let's continue with the today's lecture.